Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day. I'm Imran Mohammed, S48162, student of Faculty of Ocean Engineering Technology and Informatics from University Malaysia Terengganu. And today I would like to present my video SRD of modeling of behavior for inhibition correction of mild steel using LSTM and GRU architecture via artificial neural network ANN. Metal had been used widely in all industry, especially in maritime industry. By having a problem like corrosion, a lot of waste like cost and time consumed. Corrosion is a process of corroding or being corroded. A lot of methods were used to control this issue, but the best is yet to come. Isolate the corrosive agent like oxygen from the metal is the best way to prevent the corrosion. The problem statement for this experiment is the corrosion have been a major problem for the most of the industry. It happened due to the interaction of metal with its surrounding, which causing a detrimental effect to the metal. This study will conducted to examine the effect of caffeic acid as a corrosion inhibitor for mild steel in seawater. Due to the several factors such as cost, time and effort, the repetition of experimental is considered as non-effective. This problem statement will conduct to our objective of this experiment. The objective of the experiment is to coated the inhibitor on the mild steel to control the corrosion. Next, to determine the behavior on the inhibitor. Last but not least, to get the model of inhibitors behavior using LSTM and GRU architecture via RNN. The significance of this experiment is the application of machine learning in interpolating data through prediction and modeling study be used as a good option to overcome the problem. Next, the usage of caffeic acid as a green inhibitor are more environmental friendly. Literature review that I have been done in the research that have been done by the past research before on the corrosion inhibitor is by the Abdallah and team during 2004. The inhibitor they are using is the cheap raw material or heteroatom in carbon change and had been synthesized as corrosion inhibitors. As the method they use is weight loss measurement to determine the corrosion rate and inhibitor efficiency, and this be done by Souza and team during 2009. The usage of heteroatoms are contradictory with the restrictive environmental law dictated by Kern and team during 2001. Besides, the weight loss measurement method can be determined more accurate in consumption of the inhibitor, but the time consuming are too long, are not suitable with nowadays economic growth, and we can tell it not efficient at all. As the method that being used in this experiment is, the electrochemical analysis will be carried out by using electrochemical impedance spectroscopy (EIS). It is expected that as the concentration of the inhibitor increases, the subsequent parameters will be positively be affected by giving a good agreement in terms of inhibition efficiency. Artificial neural network ANN will use the experimental result as a data input, and its corresponding behavior model will be predicted. Two different architectures will be used, which are long short-term memory LSTM and gated recurrent unit GRU. As the expected result for this pre-disease is, it is expected that upon the addition of caffeic acid as a corrosion inhibitor, the charge transfer resistance RCT will increase as the concentration increases. The response of real and imaginary impedance Z bar and Z double bar will be associated with the input frequency. The prediction of corrosion inhibition behavior is expected to show a good fitting with high value of regression R2 and low root mean square error RMSE. As the conclusion for this presentation, it can be inferred that the corrosion inhibition of caffeic acid on mild still in seawater will exhibit a good inhibition efficiency, while a nonlinear model with high R2 and low RMSE will be obtained, indicating a good fitting of prediction model with experimental value was achieved. That's all from me. Thank you so much. I hope you guys enjoy, and Q&A will be high on the next.